Welcome back. We continue with the second lecture of Professor Feigin on affine and toroidal algebra and integrable.
Okay, so let me first formulate the following thing, that I am moving probably surely too slow for myself at least. And first let me say what I plan to say later, but connection of this business with toroidal. It is the following problem. Suppose we have first algebra E minus 1, E minus 2, and so on. I do not want to factorize it, but this algebra itself, it has two gradings. One grading is according to these numbers. Let me call first grading Q grading. And that's Q degree of E minus I is equal I. And this algebra also has Z grading. Z degree of E minus I is equal 1. No, after that, because it has two gradings, I can write down the generating function. So it will be the sum of Qi, Zj, and coefficient here is equal to dimension of subspace here, which has grading, two kind of gradings. Maybe let us put here M and N, and Q grading M and Z grading N. No, because it is polynomial ring, then for that, we have a product which is looking like this. 1 minus ZQ, 1 minus ZQ square, and so on. It is like this, and this is more or less evident. No, because if I write down this as a product, then we get just the character of the polynomial ring. But one reason is a serious reason appear actually from that. But
sorry, parameter Z in as parameter of expansion at the same time in coefficient.
No, it is bad.
It's Y is previously, no?
No, Y is also not good. Z, Y, and what?
I mean, it's the same.
No, it is different Z.
It's the same Z.
No, it is better to put some other letter here, maybe X.
Okay.
And here will be X grading of this, and it is something like this. But if you have commutative algebra, in principle, any algebra, we can make up more elaborate grading or at least filtration. Well, and inside this algebra, we have EI which are expansion of EZ. And let us put 1 here. Then I can take EI2, there are expansion of EZ squared. Then I have EI3, which are expansion of E cube Z and so on. So therefore, in my algebra, I have some collection of elements. No, they are labeled by I and also 1, 2, 3, and so on here. And if you have this, then just inside in this algebra, we can make up filtration. So this filtration is following. So you have this algebra, this is polynomial algebra. In principle, if in this algebra I have some subspace W, this W will be this later. Then, and suppose W generate our algebra. Then by this way, I can construct filtration here. F0, it is just C, constant. F1 is constant plus V. No, in principle, I do not say that constant is, in principle, it can be element of V, but anyway, I just take sum up. Yes, and F2 is F1 times F1. No, just product of elements here, and if you have Fi, then Fi is Fi minus 1 times F1. So therefore, we have now what we have now in such case we have F0 in F1, F2, and so on, and I can construct graded algebra from that. F0 plus F1 over F0 plus F2 over F1 plus blah, blah, blah. And if I do it, I can calculate the characters. It introduce new variable and charge. Y charge for this 0, this is 1, this is 2, and so on. And what is going on in our case? In our case, W is just this. So I mean, so more precisely, here I have EI. I is in less than 1. Here I have sum of E alpha, E beta. Again, alpha plus beta equal to some I, but alpha, beta run here, and next it will be the sum E alpha, E beta, E gamma, alpha plus beta plus gamma equal I, and so on. And my space W just span. It is what I have here. This is basis in my W, and using this W, I can play in this game and make first filtration and then additional grading. So, now first of all, what I get after that? After that, I get some algebra. Now here it will be 1. And it is easy to see that in this algebra, this space, in my space, in my case, it will be this, and so on. and this will be, for this new algebra, this will be a space of generators. And no, define relation are quadratic, but I will try maybe explain it later, but now I want to say the following. Well, on this new algebra, I have x grading. Yes, I have x grading. I have q grading. And I have also new y grading. Now, this y grading is here 1, here 0, here 1, here 2, and so on. So after that, I can write down the generating function. So it will be yn, qm, and nml, and here the dimension of corresponding space. And what I want to say that this is almost what I need. Actually, if I'm not mistaken, just this has the following structure. It is some ym, but coefficient is following. It will be qm square z power m, and here it will be 1 minus qz, 1 minus q square z plus so on. Maybe it is some small mistake in this formula, but it is something like that. And for Toda, we do not need this. We need like this. But it is not, actually it is not great difference. And no, technically it is not complicated to get real Toda things which appear here. But even such procedure is interesting. So by this way, we get some function depending, even here m square, but this object also satisfy difference equation, but slightly different from what I write before.
So the denominators in all terms is the same?
No, I did not finish. It is 1 minus q m z. M belongs to z, m is like this. Yes, and no, I think no mistake here now. It is, at least it is what we have here. And the message is following, that I had expression without y, which is product 1 minus z qi like this. But after that, in a corresponding space, I get some filtration and write down the new character after that. And because of some, no, actually it is not mystery, but it is not, if you want really to prove it, it is some work. But in many examples which I know, such kind of construction give you some function depending in additional variable y, and this function, no, I cannot explain it, but at least in many cases it satisfies some interesting difference equations. And maybe not today, but maybe tomorrow I will say a little bit more about this, but and now I only want to say that from this point of view, it is just kind of some strange procedure. So it means what? it means that I have algebra for E minus 1 and so on, and after that I degenerate it by such way that after degeneration in a special point it has more generators and extra grading. And this extra grading gives us no, the fact is that the same story can be understood also from the geometry of a flag manifold. It is maybe I try to explain, but let me return to this because I need to say something. No, first of all, about the...
Are you sure about this equation? Because after action of this d onto z, the first multiplier becomes 0.
Yes. And so what?
0 equal not 0.
So you're not...
The first multiplier by this shifting.
No, you think it is wrong, or what?
I think it's exactly 0.
Here?
No, on the left side. Z. No, sorry.
No. Okay. So now let me return to this. So I have it is 1, and as I said, my space is a quotient by the summation E alpha, E beta, alpha plus beta equal I. Yes, and first what I want to do, I want to describe this space in terms of correlation functions. And no, let me do it by the following way. Let me fix some functional on this space. To C. Yes, and and my space has, as I said, this X grading. So the X degree of each EI equal 1. And suppose that functional also have grading. And suppose that degree, X degree of this functional is equal to some L. Yes. Now I want to say the following. I write down, I take highest weight vector, here it is 1. Then I apply E z1, E z2, and so on, E zl. And then I calculate psi to this. First of all, why L here? No, because degrading, no, in principle, I can take one, act by some collection of Y, of E, and then consider a scalar product with psi, but it is not 0. If I have this, it is not 0, only if we have product of L things here. Yes, and so after that, it gives me psi. I correspond some function, this function, maybe it is f, depending in psi, in z1 and so on, zl. What we know about this function? First of all, because the ei and ej are 0, then this function will be symmetric in Zi. For simple, no, I do not fix other property of psi, but suppose q degree of psi is fixed, or at least psi is sum of finite sum of psi I and psi j, such that q degree of psi j, if psi j is fixed. The important that it is finite sum. From this we can deduce that f is polynomial even more than that. It is polynomial, but it is some polynomial in Z1 and so on, symmetric polynomial in Z1, ZL, but also product Z1, Z2, ZL here. It is because it is polynomial, and this is because the first non-trivial component is e minus 1. Because of this factor appears. But also we have to see this, what has to be the sequence of this relation. No, because if this functional I substitute to something from here, it has to be 0, because my functional is here. And from that, I can deduce that this P of Z1, no, ZZ maybe, Z3, and so on, ZL is 0. So if I substitute two elements which are equal, then it has to be 0. This is just a simple consequence of this, or relation that EZ square is 0 also produce such things. Simple statement is that this is any polynomial with such property we can get as the matrix element of such kind. And it is possible to formulate it by following that the space which is dual to my space, I mean L, 0, 1, E here, can be identified. No, here it is E, and I consider the part of x degree. No, because L is similar to this with x degree, maybe some n. In this case, dual space can be identified with the space of functions of Z1 and so on, Zn, with such properties that in our case this is what? F0, Z2, Zn is 0, it is these things, and F, Z, Z3, and so on, Zn is 0. And what changing in a case if you put K here? It is not big change, but all these remain untouched, but here we have F, Z, Z. Here we have K plus 1, and then it will be, here it will be any Z what we want, it has to be 0. So such kind of polynomial has to be 0 on such diagonal Z, K plus 1 times. And again, it is some kind of identification. So dual space to this, it is can be identified with the polynomials which are with such kind of properties. Now, let me continue a little bit. I want to say that I said that C plus L here E 0, 1 dual plus L again E here 0, 2 dual plus so on. They give us the coordinate ring of some manifold which is the closure of my orbit. It has to be the closure of my orbit on a flag manifold. Now, as I said, dual space can be identified with such kind of polynomials. And therefore, let us just write down this in using this. So what we have here? Here we have C. What I have here? So as I said, dual space it depending in this n. So so I want to say that what is this? It is C, which is polynomial in 0 variable, then polynomial in 1 variable, Z, polynomial in 2 variables, Z1, Z2, polynomial in 3 variables, Z1, Z2, Z3, and so on. Fine, and all these polynomials have to, on these shelves, we have our x degrees in my space, which I have, so it's summation. Each element is sum of such kind of polynomials, and such polynomials are symmetric, and they all satisfy this condition, but for k equal 1. And also here, and let me put 1 here. Here I have C, F2, Z1, then I have F2, Z1, Z2, then I have so on, and element is a collection of such kind of polynomials, and so on. The difference is in such column only in this condition. So there is 0 if I substitute 2 equal, there is 0 if I substitute 3 equal, and so on. But I promise you that in such it is coordinate ring of something. If it is coordinate ring of something, I can determine the product. And this product is given by very simple formula. Suppose I have some column and F, I have k here, and number of variables is suppose n1. So I'm here for some k and living somewhere here. And I have another function, and maybe it will be k1. And I have function f, here is k2, and here is z1, z2, and so on, zn2. The product, what it has to do. In a product, I have to go, first of all, these two numbers have sum up, and these two numbers have sum up, because they're corresponding to two different gradings. And the result of this product will be, we have to write down f k1, z1, so on, zn1, times f k2, zn1 plus 1, zn1 plus n2. Yes, and here I, because I have to get symmetrization, symmetric function, I just have to do symmetrize them in all z's. So after that I go to a column k1 plus k2, and number of variables will be equal n1 plus n2. And it is easy to see that because this is it has k1 type zeros on the diagonal, it is k2 type zeros on the diagonal. Here we get k1 plus k2, and this is more or less, no, you can easily check it, and it will be just this, and we get, by this way,
we have to satisfy also properties that when we get have k1 plus k2 equal parameters, we have to get 0.
Yes.
But
No, but it is, for example, suppose you have just function fz1, fz, and I have function, suppose, in z1, here in z2 times z3, and what is my product? This is function just here, from here, suppose no relations, and here it is 0 if z2 equals z3. Then my product is what? I have to write down such this times this, and then make up symmetrization in z1, z2, z3. So it is symmetric, so symmetrization, it will be 3 terms. This, but I have to interchange this and this. And I claim only that the result is 0 if z1 equals z2 equals z3. And I think this is more or less evident. Yes, and so a similar story happening in general. Yes, and no, again, because of time restrictions, so so here I have some kind of construction for usual SL2, and it is like manifold and so on. But suppose we want to do same story, but for UQ of SL2 head. Suppose this is a quantum deformation of the same situation. So the question, it is not very natural right now, but what I want to say. In all my business, we worked with flag manifolds or affine Grassmannian for Lie algebra of SL2 head. So it means that for this approach, I to group, then taking some kind of quotient and get what is calling affine Grassmannian, and after that I can play with this affine Grassmannian. By playing, it means that it is a sort of algebraic manifold, therefore I expect to have coordinate rings and something like that. If you go to a quantum group, then such kind of story in principle has to be repeated. But we have not this object as algebraic manifold, but we are now living in non-commutative world. So therefore, we expect that after deformation, the coordinate ring will be some graded non-commutative algebra. Yes, and actually it is possible to do, and because in a deformation we have also irreducible representation like this. We have tensor product yes, and using this in principle we can construct the corresponding non-commutative algebra. Now everybody who tried to do it, there are some small troubles, but it is possible. But I'm talking also what is happening from this point of view, and can we take currents to a nilpotent and